the main reason why 10BASE-T1S is so special compared to the other physical layers of the automotive Ethernet stack that we previously saw is that it supports multiple ECUs in the same network. So let's very briefly look at the topology of Ethernet networks. We usually have these ECUs that are switched. So it's always a point-to-point connection, so one ECU to another. And then this may act as a switch connected point-to-point to even more ECUs. With 10BASE-T1S, this is completely different. So 10BASE-T1S supports what we call multi-drop bus topology. So we can have up to 8 nodes in one 10BASE-T1S network, and the overall length of this network can be up to 15 meters with stubs up to 10 centimeters. And this allows very flexible and a lot of different bus topologies, very similar to CAN. So this is where the competition starts appearing. The data rate for 10BASE-T1S, as the name suggests, is 10 megabit per second. And yeah, as I previously mentioned, it is transmitted over a single twisted copper pair. I think if we look at the collision avoidance, this is pretty interesting because one might ask, how does this work on a technical level? Ethernet is usually point-to-point, and we have the CSMA collision avoidance. In standard Ethernet, this will not work for these multi-drop Ethernet topologies. And here we have a completely different collision avoidance, which is called PLCA. And this is for physical layer collision avoidance. And how this works is, so it's not mandatory by the standard, but usually everyone uses this because this is what it is made for. And how this works is that we have very untechnical. I think if we wanted to explain this in a detail, we would need to make a separate video out of it. But very simply, each node in the network is assigned transmit opportunities and a time slot. So it's a round-robin procedure where you have the opportunity to transmit some data. And the main application areas within vehicles we currently see, and this is where these multi-drop bus topologies really come into play with their advantages, is in, for example, sensor or actor networks, where you have a lot of different sensors and actors, or in these zonal architectures within vehicles.